Welcome to the Explainer. Have you ever seen one of those charts that kind of looks like a box with whiskers sticking out of it and just wondered what on earth is that supposed to mean? Well, that's called a box plot, and it's actually an incredibly powerful way to tell a whole story with data. So let's get into it.
Okay, so here's how we're going to tackle this. We'll start with a concept you probably remember from school, then we'll build on that with something called quartiles. We'll walk through a real calculation together, actually build a plot from scratch, and then, the best part, we'll reveal what it all means.
All right, so to really get box plots, we've got to take a quick step back, probably to your school days, because it all starts with this one key idea: comparison.
Yeah, remember getting those standardized test scores in the mail? What was the very first thing you did? I bet you asked your friends what they got. You knew just instinctually that your actual score wasn't nearly as important as where you ranked compared to everybody else.
And that's the whole idea right there. A percentile isn't your raw score. Nope, it's the percentage of people that you scored higher than. It's all about where you fit in the group.
So the most important thing to remember is that percentiles, which by the way always go from 1 to 99, they're all about your relative position within a set of data.
Okay, so now that we've got a handle on percentiles, we can zero in on the 3 specific percentiles that are really the backbone of every box plot. They've got a special name: quartiles.
Think about it like this. 4 quarters make a dollar, right? Well, quartiles divide your data into 4 equal chunks of 25%. The first quartile, or Q1, that's the 25th percentile. Q2 is the 50th percentile, and hey, you already know that one. That's just the median. And then Q3 is the 75th percentile.
Now, I know this might sound a little complicated, but it's really not. Let's make it super concrete. We're going to calculate the quartiles for a real data set. In this case, the number of beds in a random sample of 11 hospitals in Massachusetts.
Okay, here's our data. We've got the number of beds for each hospital. And you'll notice, and this is super important, it's already sorted from the smallest number to the largest. That is always your first step.
Finding the quartiles is just a simple 4-step process. We already did step 1, and since you already know how to find a median, trust me, we are more than halfway there.
So, since we have 11 hospitals in our list, the one right in the middle is the 6th one. And that hospital has 126 beds. Boom, that's our median, which also means it's our second quartile, or Q2.
Awesome. Now, for Q1, we just look at the numbers below our median. There are 5 of them. The one in the middle of that lower half is 90, and that, my friends, is our first quartile.
And you guessed it, we do the exact same thing for the numbers above the median. We look at that upper group of 5, find the middle one, and it's 254. That's our third quartile, Q3. Simple as that.
Now that we have Q1 and Q3, we can figure out another really useful number. It's called the Interquartile Range, or IQR for short. All this tells us is the spread or the range of the middle 50% of our data.
For our hospital data, all we do is subtract Q1 from Q3. So, 254 minus 90 gives us an IQR of 164. What does that mean? It means the middle half of the hospitals in our sample are spread across a range of 164 beds. Oh, and here's a quick little rule to keep in your back pocket. If you happen to have an even number of data points, your median is the average of the 2 middle numbers. Well, in that case, those 2 numbers get to double dip. One gets included in the lower half when you're finding Q1, and the other gets included in the upper half for Q3.
All right, we've done the calculations, we've got all our ingredients. Now comes the really fun part. We get to put it all together and actually build our visual, the box and whisker plot. These 5 numbers right here, this is everything you need. The absolute minimum value, our 3 quartiles that we just found, and the absolute maximum value. This is the complete recipe for our plot. Okay, first up, we draw the box itself. The bottom of the box is at Q1, the top of the box is at Q3, and then we draw a line right through the middle for the median. This box, this is the heart of the plot. It literally contains the entire middle half of all our data. And now for the whiskers. We just put a little line at our minimum value, another little line at our maximum value, and then connect them back to the box. And that's it. We have a finished box and whisker plot.
So you might be thinking, okay, cool, but why did we do all that? Well, here's why. Because this simple little shape tells us a powerful story about our data's distribution. Basically, how it's all spread out.
And this is where the magic happens. A box plot shows you the shape of your data almost instantly. See, if the whisker sticking out the top of the box is way longer than the bottom one, that means your data is skewed right. You've got some unusually high values stretching things out. And if the bottom whisker's longer, it's skewed left, meaning you have some really low values pulling it down.
Here's a fantastic way to think about it. Picture a roller coaster, right? You have that steep climb up and then that long, gradual coast back down. Well, that long tail on the way down, that's exactly what a right-skewed plot is showing us. And if we look back at our hospital data, that long top whisker tells us a story. Most of the hospitals have a pretty similar number of beds, but there are a few really, really big ones that stretch the data way up.
So there you have it. We went from a single test score all the way to a full data story. The box plot is such a simple but really profound tool for seeing the shape of information. Now that you know how to read them, what stories are you going to find?